In this video, we're going to be learning about async parallel calls in Langchain. Langchain introduced async support back in February 8, and it allows us to make multiple calls to the language model using the same prompt, or for example for chunk summarization. And it gives us an incredible speed boost, a significant speed boost. Let's start with a demo. We're going to be talking about making regular calls to an LLM, making calls to an LLM chain with input parameters, and also making agent calls in parallel as well. For the regular LLM call, we're sending the prompt, tell me a sentence about the interestingness of Capricorn's constant 5 times, both serially and concurrently in parallel. When we run this, just give it a moment. As you see, our concurrent is executed in 2.10 seconds, and then our serial process is executing, and it completes in 7.73 seconds. So we get 4 times speed upgrade with this. Let's try the chain. This chain again sends a prompt. Write a single sentence about Capricorn's constant, that is tone. Tone is defined with our input variables within our prompt, which we're using to define with the prompt template. We're going to talk about this here shortly. But when we run this one, we are both getting the concurrent calls executed, all 5 of them, in 1.69 seconds. And then after that, the serial is executed, and it takes 5.30 seconds. Again, we have about 3 times speed up in this case. And the agents. So we have 3 questions prepared already. What is the amount of letters in capital of France times 10? What is the population of the world divided by 5? What is 1/10 of the height of the tallest tree in the world? We are using some tools here. Of course, LLM Math and SERP API, which currently work with async. Not all tools work with async support currently, as of the time of this video. But when we run this, we see that we enter agent executors chain. This is in serial mode. We do a Google search, and eventually we find the Paris, which is capital of France, which is 6 letters, and we times it by 10, get the answer 60. And then we search for world population. It finds the world population, divides it by 5, and gives us the answer. And searches for the longest tree in the world, and then divides it by 10, 1/10, right? So this was our concurrent calls. And it took It took 22 seconds for the serial. And for when we do it parallel with async in concurrent, it takes 6.65 seconds. So the speed up here is about 4 times. Let's begin by how we can implement async with Langchain. I will put all the links I'm showing you in the description. This is from Langchain's blog. I will be using Conda, mini Conda, for custom environment, virtual environment creation, which is very useful. There's a real Python async IO complete walkthrough if you want to learn more about async. Here's the async API for LLM, for chain, and for agents from Langchain documentation, and also the link to Wikipedia article about Capricorn's constant. I find it fascinating. Maybe you will like it as well. Our requirements for this is pretty simple. We only need Langchain and OpenAI for the LLM and chain implementation. We also need Google search results because we are using SERP API with the agent. This is for Google searching when it is necessary as a tool. When I'm starting a new project, I always like to start from scratch with a new virtual environment. To create a new virtual environment with Miniconda, I have put the link to Miniconda in the description. It's pretty easy. In Visual Studio Code, start your terminal, and then with this arrow button, start a command prompt. And after that, you have a base environment, and then I already have created an LC_async environment. But the way we created this environment is Conda, using the Conda create -n, and then the name of our environment, LC_async. And then we can specify a Python version, Python equals 3.10. For example, we have to make sure we don't have any typos. Python equals 3.10. So this will create a new Conda environment. I already have created it. And once you create your environment, you can actually activate it by saying, let me deactivate this environment real quick. If I type in conda deactivate, I've deactivated my environment and went back to base. And then I can type in conda activate LC async, and then it will activate my environment. Now after this, you need to pip install some requirements, Langchain. you would have to pip install Langchain, and then pip install OpenAI, okay, for LLM and chain, and also the same for Google-search-results for SERP API. And after that, maybe you need to restart your Visual Studio. Let's begin again with a code review. I just want to say I will make this code available for download for my Patreon supporters. I will put the link in the description, but feel free to follow along from the video as well. So the first thing we want to do is a regular LLM call. We import time to keep track of time while our code is executing to see the performance difference using Async IO, which we're importing. Then from Langchain LLMs, we're importing OpenAI chat because we're going to be using the new GPT 3.5 Turbo chatgpt API. We already talked about the importance of making async parallel calls. We already talked about the requirements of pip installing the necessary packages. I have already defined my API key in my user environment, but you have to define it. And then we define a serial function. This is our function to generate serially. We are defining our OpenAI LLM to be OpenAI chat at temperature 0.9. And then we make a loop for anything if in range of 5. This is just a placeholder. We want the response to be what the LLM.generate and then our prompt. Tell me a sentence about the interestingness of Capricorn's constant. This could have been anything you would like it to be. I just chose this. Why not? And pay attention that the OpenAI chat completions is a bit different. We do, if we want to print its completion, we do resp, which we are receiving right here, dot generations, the first element, dot text. Pay attention to this, please. This is to generate serially. This will send this prompt to OpenAI's API, one after the other, and get the response and print it. Here, on the other hand, we are defining an async function, with the async being in the beginning of the function definition. We say async underscore generate LLM. This async generate function does receive an LLM parameter because we are defining a general async generate function. And we are going to generate concurrently function, which will define the LLM right here, and we will pass that LLM into the async generate as LLM right here in the line 27. But before we get ahead of ourselves, pay attention that we are defining the function with async, and then we are awaiting for the response with LLM.aGenerate. The syntax has to be like this. And then our prompt, such as this. Then we are just simply printing the response as we did with the serial function right here. So this function will send this prompt into the LLM each time when it's called. Then we define a function to run the async function concurrently. We're defining a list of tasks here. Pay attention. Then we are again defining with async a function which says generate concurrently. This function defines an LLM, which is OpenAI chat, GPT 3.5 Turbo, at temperature 0.9. And we are defining a tasks list with async underscore generate function for placeholder in range 5. We are going to make 5 concurrent calls with this tasks list. Then async.io is a function that takes a list of tasks and runs them all at once. Then we await the result of that function with async.io.gather tasks with a star in the beginning. Some of this syntax might seem confusing to you, but Langchain is a framework. You have to just operate with whatever syntax is provided to you. Please read their documentation, as I will be putting the link in the descriptions. And after that, after we have defined our generate concurrently function, we are actually setting using the time library that we have imported a start time using the time.perf counter, probably perf stands for performance. We define a start time, and then we call async io.run generate concurrently. You have to call it like this. And then we check for the elapsed time by saying elapsed equals time.perf counter minus s, which we have defined right here. This will give us the difference between the time from when this function starting to execute to when it had ended. And now here we are printing it simply by first introducing a line break. It's like pressing enter in your keyboard. And then we are doing an f string, and then we say that concurrent executed in the time which we have calculated down to 2 decimal points. The syntax is like this, and then we just say seconds to indicate how many minutes and seconds have elapsed. Okay, and then we start another start time. Then we generate serially. We generate serially, as you remember, we define up here. And after that time, we take notice of the time when this function had ended, and then again we print it. Okay, let's run this real quickly again so we can see it better in action. Here we go. The concurrent is pretty quickly done in 3.75 seconds. And the serial has started. As you see, it's pretty slow. Okay, we're still getting some answers in 9.88 seconds. So this is a pretty nice speed boost for us. Okay, let's move on to our second file, which is chain.py. As I said before, this will be available for download for my Patreon supporters. Link will be in the description. So as far as LLM chains, we are still importing async IO and time, and then we are importing OpenAI. We will be making regular calls with the TextDaVinci 003. We are importing a prompt template because we're going to be defining some input variables. And we are importing from Langchain.chains import LLM chain. Some things to take note here is that async methods are currently supported in LLM chains through arun, apredict, acall. We're going to be using arun, I believe, right here. Yeah, that's true. And LLM math chain through arun and acall. ChatVector chain is available. QA chains is available. Async support for other chains is on the roadmap. Okay, just please check Langchain's documentation. Again, we define a function, generate serially. We define our large language model to be OpenAI temperature 0.9, sorry. And this is TextDaVinci 003. Then we are defining our prompt using the prompt template, which we have imported right here. And we define an input variable called tone. In this case, I've chosen tone because I'm going to just define the sentence which is returned to me, and I want to specify the tone in which I want it to be written. Then a template here, and please pay attention to the syntax. Write a single sentence about Capricorn's content, that is, and then we input the tone here. Then we define our chain. We're going to define the tone as funny and exciting. It could be really anything you like. Then we define our chain as LLM chain, which we have imported up here. We say that in its parameter space, LLM equals to the LLM, which we have defined right here, and prompt equals to prompt, which we have defined right here, and it takes an input variable. Then we make a loop for a placeholder in range of 5. Then the response is chain.run. We are running it serially, so we can run it with just .run. And the tone is funny and exciting, and then we simply print the response. Then we define an async function with the async parameter here in the beginning of the definition of the function, async_generate. And then we will input this function into the generate concurrently function, which we'll define later, and the chain will be defined right there. Okay, then we will be inputting the chain as a parameter here, as we are doing in line 38. When we're defining this generate concurrently function, first async def async generate takes in a chain parameter and then gets the response with await chain.arun. Pay attention to arun, and tone is funny and exciting. This is very similar to the serial calling of the chain, but this time we're using await and arun. Okay, and then we're printing the response. But then with concurrent calling or parallel async calling, we do define another function like we did before with async. Define generate underscore concurrently. We define an M. We define a prompt, same as we have done before. Then we define our chain to be the LLM chain like we have done before. LLM being LLM, which we have defined right here. Prompt being the prompt, which we have defined right here. Then we have to assign a list. Okay, and we do this with square brackets, of course, because Python. Async underscore generate, and we input the chain, which we have defined right here as a parameter for a placeholder in range of 5. Okay, so we are making it in a single line loop using list comprehension, and then we await async io.gather and then tasks as we have did in the other file. Then again, we set at the beginning of our time counter, just as we've done before. Then we run the async io.run generate concurrently. Okay, this function right here. And then we look at the time that is elapsed, and then we print it. And then we do this exact same with generate serially. Here I just want to mention a few little bonus points. As you see, there's some complex looking syntax in the print function. It turns out that this /033 and 1m is to actually format the text that is printed. For example, in this case, 1M is sets the text to be bold, okay? And then we say plus with our F string, and then we actually end that formatting, okay? So this is important. Make sure that you have to start it and then end it. The syntax to do that is exactly like this. But if you wanted to, for example, instead of, so in this case, we are printing the time that is elapsed, this print text in this format, okay? And this format corresponds to the bold formatting. If you were to use 2M, then it would be faint. Here are some options. 3M is italic, 4M is underline, 7M is inverse, swap foreground and background colors, 8M is hide text, 9M is set text to crossed out. Just keep that in mind. Anyway, this is just some extra information for a print function. Now let's just run this and see again what is happening. First, we're going to run our concurrent. Look, see how quickly we got our responses in 1.66 seconds. And our serial execution took 4.44 seconds. Okay, the interesting thing here is that we are using a prompt to be able to input a tone. We could have changed this funny and exciting to anything we like. Okay, keep that in mind. Okay, our final file is how to run agents with tools in async parallel in a parallel manner. We are again importing async IO and time. This time we are importing from Langchain.agents, initialize agent, and load tools, because we will be using LLM math and also SERP API Google search. We are importing regular OpenAI. We are importing callbacks, std out, callback manager, and the callback manager. And then we are importing the tracer, but we're not actually going to use this in this case. And then we are importing HTTP from AI HTTP client session. This from Langchain documentation, I realized actually increases the performance of doing parallel calls with async to OpenAI's LLM using HTTP requests. But it works without using this. You get the speed boost anyway. We're going to talk about it here in a second. I know I've just heard AI or HTTP for the first time making this video, so don't get discouraged. Please continue, just pay attention to syntax. One thing to notice here is that other than our OpenAI API key, we now need our SERP API key to be defined. I have it already defined in my user environment variables. You need to have set up your SERP API account as well to have an API key, and just read it and just do some Google search on how to achieve this. Okay, it says that async methods are currently supported for the following tools: SERP API and LLM math chain. Other tools are on the roadmap. Okay, just check Langchain's documentation for future updates. Now we are predefining some questions. In this case, what is the amount of letters in the capital of France times 10? What is the population of the world divided by 5? What is 1/10 of the height of the tallest tree in the world? We're just going to ask these questions to our agent. We again define our generate serially function. Then we say for queue in questions. See, this was a placeholder. In the previous examples, we saw that it was an underscore. It really doesn't matter. This is just going to be a placeholder for whatever in question. So it will go this one and this one. Okay, this is how for loops work. We're defining our LLM, OpenAI, temperature 0. We're defining our tools with load tools, which we have imported right here. And then we are assigning LLM math and SERP API to it. Pay attention and be careful with the syntax. And our LLM is the LLM, which we have defined right here. Then we are initializing our agent to the variable agent. Initialize agent. We are given the tools which we have defined, and then the LLM, which we have assigned right here and defined right here. And our agent is going to be the default zero-shot React description, and verbose is going to be true, so we can see the thought processes of the agent. And we simply agent.run with the queue, which is going to be in the loop, individual questions, which will be extracted out of this list. Then, this is the definition of our function. We set the start time, and then we execute serially. We look at the ending time, and we print how long it took. Then we define generate concurrently function right here, and we make an empty list for agents at first. We're not defining a different function this time because we're going to be defining the agents within the generate concurrently function. Just in a moment, we are again using the async, and we are going to await. Actually, I just realized that we are not awaiting after calling the async. To be honest with you, the working with agents in concurrently in async manner is a bit of obscure. I would just recommend just follow this format. It is what you might call a strongly opinionated language. So let's just go through it. Okay, you first define a list, which is an empty list in the beginning. Then you define AIO session to be the client session. And then for placeholder in questions, because we have our questions list. Okay, we are defining the manager to be the callback manager. The syntax has to be like this. We are defining our LLM to be OpenAI, temperature 0, but with the callback manager to be the manager, which we have defined in the line before. Then we define the async underscore tools to be the load tools, LLM math and SERP API. LLM is LLM, which we have defined in the line before. AIO session to be AIO session, callback manager to be the manager. Then we append to the agents list, which was empty, right? We have predefined it right here. We initialize the agent with async tools to be its tool set, LLM being its LLM, which it's going to use. Default zero-shot React description agent. Verbose true, so we can see its thought processes, callback manager. Then we have generated our list of agents. Then we define our tasks with list comprehension. Then we say async underscore agent dot a run for each question for the async underscore agent for question in zip. Okay, you just going to have to read about zip different. I am not too clear on zip Python method, and then you input all the agents in the questions. Agents was a list, remember, and questions was a list we have created. So it is looping for the agent and the question in the agent list and questions. And then it runs the async agent for that question using, pay attention, .a run. Then we are awaiting, actually, maybe I said we are not, but we are. Sorry about that. Async AIO.gather.tasks, and then we have to do this, which is await AIO session.close, as it mentions right here. Okay, now you don't have to use AIO session. I will show you how to skip that part, but it just gives you additional upgrade in speed. Then we check out, log our start time, run async IO.run, generate concurrently. Okay, and then we'll take a look at the elapsed time, and then we print. Now let's run this again and see what happens. Okay, our first one is going to be serial. So we are doing a search for capital. So it actually does a mistake in second search, but essentially it ends up finding the right answer. Agents can do that sometimes. Okay, our third one, Hyperion, apparently. Height of Hyperion is 380 foot. Anyway, and then so it's so much faster for the concurrent call. I just want to mention this one took 22 seconds. And our concurrent calling took 7.5. Now, if you wanted to skip this AIO session, okay, if you think it's complicated or difficult, all you have to do is just either delete that line or comment it out. You will also have to comment out the closing of that session. It mentions this in the documentation. Now, we have commented out the starting of the session and ending of the session. But we have left it in the definition of the tools. Now all you have to do is just delete this part. Don't forget the comma at the end. Okay, we leave everything is, and if we run this, our code is going to work perfectly well, just without the AIO session, but it's going to slow down a little bit. Here we'll see our third one is going. This is serial execution, and as you see, 18 seconds for serial. And our concurrent calls are much faster, and it took 6.21 seconds. I believe this was still, yeah, shorter. Actually, this should not have been shorter, but also we're dealing with other areas such as how busy OpenAI servers are. But believe me, I've tested this before. Leaving this on, let's just go back to how it was. Makes it about 10% faster, maybe. Something like that. I know the agent part was pretty complicated. Please join our Discord server if you have any questions about it. And like I said, I'll have these codes available for my Patreon supporters. Link will be in the description. And I hope you enjoy this, and I hope you'll make good use of this code. And take care and see you on the next one. Thank you.